Hello, I'm Juan Garcia. I will explain the process I went through to get this field situation, or what I consider to be a field, according to what Mark and me what we want to do. So let me get started because this is a little more complicated than what it looks like at first glance, and it's going to get even more complicated, especially here at the instance of the main surface, which is up, and then the supports, which are going to be down. So basically, this is a projection of wind currents. So that's why it's like extruded towards the bottom at the instances of the columns, if you were to call them that. And then it will have the projection of light at the surface where it's going to get a subfield situation with undulations of the surface. So let me get started by explaining how this works. So basically, we start off with a grid, and the grid is composed of hexagons. It's a hexagonal grid, and from this hexagonal grid, we're going to extract each one of the lines, and we're going to create the pattern. So we start off by exploding the lines, then we start off, we follow up with creating the curves, then exploding those curves, and follow and like a sequence of exploding and unifying several curves until we get the desired pattern, which is here, where we get the pattern with the center cut off, which is this curve. So to cut off the center, or kind of like the projection axis, which is what I call it, we first off we find the area of the hexagonal grid, and finding the area we're going to be able to find the center point. That is one way. The other way is to find the average, and that creates also the center point. We list the item being the center one, and that's how we get it. So let me show you the average of the points. So we have the points, the centroids of each one of the hexagons, and with the centroids of each one of the hexagons, we gather the average, and with the average, we find the closest point to the center. We list the item, which is a center point, and from that center point, we trim the surface, creating a projectable surface. After that, we create the curves of the trimmed set of curves from before, the ones from the hexagons, which is quite literally a shift of the hexagons juxtaposed over each other and then trimmed off. Then it's a matter of analyzing data. So we get all the lines created, and we need to reduce the data to not less data, but we need to be selective with the data that we use, because we cannot use every single line by itself and just kind of like extrude them or project them by themselves. We need to have them as a set of polylines or single lines. To do this, we print the tree, and then after printing the tree, printing the tree, analyzing data, so it's easier for you to see, we have a bunch of data, which is not manageable, because managing a lot of data is going to be way harder. However, if we do this and we analyze the print 3, we're going to notice a slight reduction on the data. There we go. So that's the difference. Once you have printed 3 and you have reduced this data and then compared to this data, then it becomes more manageable per se. So we start off by extending the curves towards the edges, but before that you need to select the curves that you're going to flip, and with the reference to the centroid, of course, you need to start trimming the curves that we are going to use, which are the print tree with the selection of curves. Out of this, we have a bunch of curves we have selected, we have printed tree, and now we have only a bunch of curves that are related to the center. after doing this, now we have a projection pattern. With the projection pattern, now we extend the curves towards the boundary that we have created in order to be able to actually project the entire curve. You know that the curve itself is going to run short. And after we have done that, we find the average, and now it's time to build a circle. So the circle, which is the pattern that we're going to follow, it's going to be this. And then we're going to extrude it. That's the base of the column, and we're going to start moving it in a sequence. Once we start moving it in a sequence, then let me deactivate this three. Let me disable them for now while I explain this, because if not, my computer is not going to like me. Anyways, so once you start moving the circles, then you start to create a columnate, or you start to create the different sections of the columnate. Once you do that, then you will want to start scaling the scaling, pardon. That's why we have the remap numbers. We need to selectively start scaling with the reference at the center the circles in a manner where we have the graph mapper, which is going to help us get different shapes and get different projections of the pattern, which is what I'm going to use for the surface. But I need to get to that part. Now this worked. Now I need to get to the part of the surface. It's like a step by step. So first off, I wanted to get the supports done, and now I'm going to move on to the surface. So I have this, and now here on the scale we have this graph method, which is going to alter the way the surface behaves. So if I wanted to do a different behavior other than the conic behavior that I have, I can always do a quotient, which is going to create a different behavior and therefore a different type of field. So it's all a matter of the actual projections of things, and then after I do that, if I loft the curve, it's going to look something like this. Alright, but for now, let's leave it as I had it, as a conic relationship, which is what I want for the supports. Here we go. Now, after we have created the conic relationship, we have lofted the surface, we need to join the preps. So now we have the texture, we have created a surface also for the texture, and now we need to unify the preps so they are both a single prep and they can be projected. Now it's time to actually project the sequence, and this is how it looks like projected. Well, first off, this is the prep, which is the surface alone, and the columnate, which can be altered with all of this code here, and this is the pattern that is going to get projected. So the idea is to create a pattern that is going to function as a subfield of the main field, and it's going to get projected into things. Now, after doing this and doing the prep, then we project. So let me just have it so you can see it. There we go. So we have the pattern at the bottom. We have the surface that we're going to project on, and then it's sort of like pushing or pulling the texture onto the surface. So it starts to create this this field sensation because it's altered by different motions or behaviors. So it's the pulling pushing of the grid behavior that we're actually striving for. Now, after doing that and projecting it, now what we want to do is, again, we have a lot of information because it's a full on projection. So we have a bunch of values that are going to split on more values that are going to split even on more values and split in even more values. So after that, we need to trim the tree so we have less values that split into less values. After that, we loft, and now we have a surface of the projection. Now, having a surface, we can now extrude the surface into different offsets, or create it as an offset surface. Let me enable it and let me display it. We offset the surface, we give it a thickness, so it's actually something that we can produce in a 3D printer. We make sure the edges all align, so we have the connections. Again, the connections that I made are not rectangular connections, but rather they have these indents, so we can actually do a seamlessly connection. Just thinking about you have shown us before, so far. And after doing that, it's just a matter of repetition. So it's a rectangular array with different full-on repetitions of the same form, and these repetitions are based off on the same centroid. And after that, we just give it a color, and then start manipulating it more. So now what I'm going to move on to, it's manipulating the surface, the upper surface, which is the unifying perhaps here. So this boundary surface, that is basically this, it's the one that is going to get code here in order to manipulate the surface, connect it, create different variables for the grid, and then start creating a subfield that is going to be projected onto this. That's what I'm going to have prepared, but for next class I will probably have the print of the whole array, of the whole silhouette that I'm going to create, and then once I have the whole array and the plan, then we can start seeing how the project is going to start looking and projecting onto itself. But for now, computer wise, this is what we have with the code. Again, I'm working with Mark, and this is what we have. Thank you, Professor.